Stick around to the end because the final experiment will completely change how you think about plastics.
Have you ever noticed that when you heat a plastic bag or a strip of polythene, it shrinks instead of expanding? It feels backward, right? Almost everything else expands when heated: metal rods, air, even the water in your kettle. So why does plastic do the exact opposite? Well, the answer is a beautiful mix of physics, chemistry, polymer science, and a little bit of entropy magic. Let's break it down.
Hey everyone, welcome to Mind Blown Science, your place for exploring the biggest ideas in science, physics, and mathematics. If you love learning about the universe, from quantum mechanics to cosmology, you're in the right place. Don't forget to hit subscribe so you don't miss any of our deep dives into the wonders of science. Why does polythene shrink when heated instead of expanding? Most materials expand when heated because their atoms vibrate more and push each other farther apart. But polythene and many plastics aren't like most materials. They're made of long chains of molecules called polymers, and the arrangement of those chains is the key to the mystery. Reddit commenters in the thread, r/AskScience, explain the concept perfectly, and it aligns with polymer physics. Plastic shrinks because the polymer chains were previously stretched, and heating lets them relax back to their natural, tangled state. Let's break it down clearly. 1. Polymers are long, tangled chains. Polythene molecules are long chains. Imagine cooked spaghetti. Naturally, these chains are coiled, twisted, and randomly tangled. But during manufacturing, like making plastic bags or shrink wrap, the polymer is heated, pulled and stretched, then quickly cooled. This process freezes the chains in their stretched, unnatural state, like stretching a rubber band and sticking it in a freezer. This state is high energy and low entropy.
2. Heating lets the chains relax. When you heat polyethylene again, the extra thermal energy allows the chains to move. They begin to snap back to their preferred curled, tangled form. The whole material contracts. Reddit explains it simply. The shrinking comes from the release of internal stresses stored during manufacturing. Heating gives the polymer chains the mobility to return to their higher entropy state. This is exactly correct.
2. Entropy wants the chains to be messy. In physics, systems tend toward higher entropy, meaning more disorder. Stretched plastic is orderly. Heated plastic becomes messy again. So the shrinkage is literally the material trying to return to its natural, disordered energy minimum. This is why shrink wrap packaging works. You stretch the plastic, wrap it around an object, heat it, and it tightens perfectly around the item.
Why don't metals do this? Metals have rigid, crystalline atomic structures. Heat makes atoms vibrate harder, crystal lattice expands, metal gets bigger. Polymers don't have rigid lattices. They have long, mobile chains, so their behavior follows entropy, not lattice expansion.
Real-world examples. Shrink wrap. Stretched during production, so shrinks around bottles and electronics. Heat shrink tubing. Used in electrical wiring. When heated, it contracts around cables for insulation. Plastic bag crinkles and shrinks near heat because the polymer chains regain freedom and relax.